Hello, today we're talking about paleoclimate and ice cores. So paleoclimate is just what the climate was like in the past, and we'll talk about what ice cores are here. We have this map of Antarctica, and you can see by the color, it shows how thick the ice is at different parts of Antarctica, going up to or close to 4,000 meters. Very, very thick in some parts of Antarctica. Ice has been accumulating in Antarctica and Greenland for hundreds of thousands of years. Older ice is on the bottom and newer ice is on the top. So going down into the ice is like going down or back in time. We have a cartoon kind of drawing here. It shows the ice, the new ice, recent, and the older ice on the bottom. As more ice accumulates, it goes from being these flakes to being compressed ice. And everywhere you see gray are pockets of air here. As ice gets buried by newer layers, some of the air gets trapped between flakes. These air bubbles trap the air from when the ice formed and keep that air locked away. So these air bubbles down here have air in them from whenever the time that snow fell. And it stays that way. The gas just stays trapped in those pockets. Now, one of the things that we can do is drill straight down into the ice. This is a pretty common practice, and then we can take out what these long tubes of ice called ice cores. We can drill down into the ice and remove ice cores from deep in the ice sheet. We have collected ice cores from as deep as 2 miles below the surface of the ice sheet. The ice cores can then be cut open to analyze the trapped air. So here's the ice core, and you can slice into it, and they do this in a environment where it won't be contaminated, and then they can just draw out the gases that were trapped in there, analyzing them and seeing what percentage of each types of gas there are. This air tells scientists what gases were present in the atmosphere at the time the ice formed. Now, one of the things that we can collect is oxygen and oxygen isotopes. These are just a different type of oxygen is all. But what oxygen isotopes can tell us is pretty accurately what the temperatures were at the time that that air got trapped, or when those oxygen isotopes were present. We can collect gas samples such as oxygen, carbon dioxide, and methane. Oxygen isotopes can tell us what the atmospheric temperature was at the time the sample was trapped. So we have a record going back in time of when it was hotter and when it was colder. This here shows several pieces of data. We actually have CO2 levels, methane levels, we have oxygen levels, and then there is temperature here in red. And you'll notice, especially these top 4 here, they all match. As one spikes, the other spikes. As one goes down, the others come down. When comparing all the data, we can see that every time CO2 goes up, temperature goes up. So this is what's happening right now. We're putting extra CO2 into the atmosphere, more than we've detected in the last 400,000 years. And as CO2 levels go up, every single time the temperature has gone up. And that's what's causing global warming. All right, thank you very much.